This video was supposed to be an in-depth look at how I added dual extrusion to my Ender 5 Plus 3D printer. And what's great about this process is that no matter which 3D printer you have, as long as it's running a version of Marlin firmware, this process is pretty much the same. So this would work as a tutorial for anyone looking to add dual extrusion to their printer. Well, unfortunately for me, not all components are made equal, and when you just buy some of these components off of the internet, you don't know what you're going to get. And so you're going to see how I did not succeed in adding dual extrusion to this printer, but I'm still going to get to show you the process, and I'm going to show you what went wrong on my setup to hopefully help you in the future. That's what I'm doing right here today on Kersey Fabrications. Let's go. Thanks for joining me here today. I think the best way to go through this process is let's start at the beginning. I'll tell you about my goals, and then I'll just walk you through how I got to where I am right now. So before I get started with the actual modifications on this printer, I want to start with a few notes just so I make sure that we're all on the same page. Number one, first and foremost, do not attempt this mod if you are not comfortable pulling apart your printer, changing out wires, potentially having your printer down for days while you're trying to figure all this out. This is important because this mod, unlike other mods where you're just changing out one component at a time, this involves a lot of work, this involves a lot of tinkering. So I wanted to get that out of the way. Don't expect that this is a one and done kind of mod. Number two, before you attempt this mod, please make sure that your printer is already working in peak condition, so that you're not starting with something that already has a problem before adding more problems on top of that. I think that's really important. Number three, what I'm showing you in this video is a work in progress to me too. Unlike some of the videos where I've sort of pre-prepared and everything is set up and is going to work just right, I can't promise you everything will go as planned in this video. So what I'm showing you is my best practices. I'm showing you what I know and what I've learned about doing this kind of mod, but nothing is guaranteed. Not much has been pre-laid out or pre-planned other than some of the models and stuff that you see here that I'll present as I go. So that's important, that this is not exactly the tutorial that you may be used to on this channel. This is one of my work in progress builds, kind of like the linear rails mod that I did way back on the Ender 5. So now that we've level set, let's get going with this mod. So there are three things that we're going to do when we go about this dual extruder mod. Number one, we have the hardware mods. This is the physical modification to the printer. This is going to include the extruder itself. We have a Bowden tube, we have a new Hotend, we're going to need a place to put our filament, and then of course we have all of the electronics work that we're going to need to do on this printer. The second part of this is going to be the firmware changes that we have to make. We are going to need to let Marlin know that we've added a second extruder. So along with that, please keep in mind you are going to need a main board with dual extrusion support to begin with. Something like the SKR 1.4 will work fine for this mod. In fact, that's what I'm going to be using in this printer. And then number three, we're going to make slicer changes for this new modification because we're going to have to do things slightly different as we're switching between tool heads. Now, some of that could be done in firmware, but I find particularly with tinkering that the slicer is the easiest place to make these changes because it doesn't mean we're flashing the firmware over and over, but we can just make changes in Cura as we're going along. So let me show you what I have laid out here for the hardware modification to begin with, and that will be our first step. Oh, and one more thing. Unlike some of my videos where I walk you through every little step of the process and show you how to put every screw in place, this again isn't going to be one of those videos. This is a much more advanced mod, and I'm not going to have time to walk you through how I made the wiring, how I attached the extruder to the extruder motor, that kind of thing. I will either fast forward through or just skip ahead entirely as I explain what I'm doing, and that's just to save time. There are parts of this video that are more advanced that I'm going to want to walk you through every step to explain what I'm doing, but some of that more basic stuff, wiring, just mechanical screwing together, things like that, I'm going to skip over and save more time for the more technical stuff that I'm going to want to explain. So as we begin our journey on the hardware modification, I wanted to start right here because this will give us the best look at what we're going to add a second extruder. So how does the path of filament go for a 3D printer? Well, first of all, we start with the spool holder because that's where we actually hold our filament. We're going to need somewhere, particularly on a printer like this, where we can keep our filament. So I don't have another one of these, and this printer is so big you really don't want to put another spool holder next to the printer unless you have a large workspace or maybe somewhere overhead to actually add that spool holder. So what I have done is I went and designed basically a copy of this one right here in Fusion 360. Obviously, I'm going to make this available on Thingiverse and maybe some other sites to where you can download this. And as I mentioned, it's pretty much just like this one. I designed it around a filament 1 spool, which is kind of deeper than a regular spool, so it should hold most filaments. Now, one thing I know about filament is if you print this out of PLA, probably PETG, you're going to run into a problem that this is going to sag over time. So what I did on my printer was print this out of polycarbonate, particularly carbon fiber filled polycarbonate, because it's strong, it's lightweight, and I don't think that we're going to have to deal with any warping over time. Again, that'll be available. Now with this, you're not going to be able to put it here, obviously. You're going to hit your power cable if you do that, and we don't want that during a print to actually hit the power that's going to the build plate. So what I recommend doing is just flipping this around. If you have room and if you can easily access this, then you can put this right here flipped around. Now this isn't going to be convenient for everyone. Like I said, this is more of a tutorial. This is what I've done. So if this doesn't work for you, you're going to have to find another place to put this filament holder. Obviously, maybe you don't have this power supply here like I do. Maybe yours is still internal, in which case you could put some sort of spool holder from the bottom that would be easier to get to. But step 1, spool holder right here, or whatever you're going to do. I think that'll work best. Next up, once we get the filament going, it's going to go into this filament sensor. Now, you obviously could not put a filament sensor on your second extruder if you didn't want to, but to me that seems like halfway doing the job. You're going to have one here. You don't want to run out of filament on your other one. What's the point? So there are any number of filament sensors that you can buy from third-party companies. I couldn't find this one easily or this whole mounting assembly easily from Creality. So I have designed my own, mainly because I couldn't find any decent reviews on those third-party ones to know what would be reliable. You're welcome to try any of those out. The other thing I wanted to do was be able to mount it easily. So this is based upon another model that I had that I was designing for another printer. And, well, I went through a number of other designs here before I got to one that actually worked for me. But what's great about this design is it puts the filament sensor on your extruder just like this one does, but right up against the extruder. And the only thing you'll need for this is a little switch that you have wired up ahead of time to attach to this. I will show you the assembly of this in just a minute before we put everything together. And this right here will just attach right here next to this one, and you will be ready to go with your new extruder. Obviously with that, we will need another NEMA 17 just like this one, roughly the same size, hopefully with the same wiring. I will leave you a link to the model number of the one that I've used, but again, this will go right here, and I will show you how to put all this together, at least in short form here in just a few minutes. Now, once we have all of that physically set up here, obviously both of these are new electrical components, and we will need to be able to run the wiring from these two components back down to our box. That's going to go back to our main board. Now we come to the hot end, and when it comes to dual extrusion, you have two options. Well, I'm going to say two options because there's two main options for dual extrusion. Number one, you can go with a 2 input, 1 output hot end, and what that'll allow you to do is take both filaments into one place, and that means that it works just like a traditional extruder, meaning you don't have to align 2 different hot ends, 2 different nozzles, and get them printing in the same place. It will always come out the same place. The only thing you really will have to do at this point will handle the retractions between the 2 inputs, which should be pretty easily either in firmware or in Cura. The other type of hot end that you can do is 2 inputs, 2 outputs, where each one of the extruders is going to have its own nozzle. Now that's kind of nice because now you don't have to pay a lot of extra attention to both of those paths, getting one filament out of the way while you put the other filament in, but with the added hassle of lining those 2 nozzles up, not only X, Y, but also Z, making sure that they're printing in the exact right place every time. Now, which one of these seems simpler to you? You know, that's up to you. I like the 2 inputs, 1 output, and that's why I went with something like this. And what I really wanted to do for this mod, like I do on all the mods that I show on this channel, I really try to go for things that are drop-in as possible. There are much nicer versions, much bigger versions of these sorts of hot ends, but I really wanted to try out of the box to go with something that was relatively drop-in for this printer. And as you'll notice, this is pretty much the exact same design than the one that comes with the printer. One thing I did notice though is that this one's a little thicker. So what you may notice on this printer is that I have switched back to the stock cooling just to make my life a little easier when it comes to the setup and connection of this. I didn't really want to have to worry about the Hero Me Gen 3, which I don't think is going to fit over this. So let's just do one thing at a time and get this installed correctly. So there's your overview. Now I'll take a little bit of time looking at each of these components and you can see what I've done. So let's go over each of the components a bit more in detail before I actually do the final installation. So first of all, this is the spool holder I designed. Again, this is based upon the original design that came with the printer. And as you can see, I've built in the supports, the rigidity into the model to keep it from flexing as much as possible. To give it extra rigidity, I printed this out of carbon fiber polycarbonate, which obviously you're going to need a all metal hot end to print because this is some of the higher temperature filament. The only thing really to mention here is this has 5.5 millimeter holes on it. If these are not loose, you're probably going to want to drill them out just a little bit, very carefully, particularly if you're printing out of polycarbonate, just to make sure that these remain loose. Again, you've got your T-nuts on here, and this should make for a pretty easy installation wherever you can find a spot for it that meets your needs. Next up, we have the motor mount and filament sensor that I designed. Now, if you're wondering how you print this, it's going to be printed just like this, and you're going to have supports underneath this area right here. So the motor is just a standard motor that we have just like on our other extruder. So the motor is going to mount just like this onto the back. I'm going to have my cabling going down or to the side. Then I'm going to mount the extruder directly to the front like this, and my hose coupler is going to be facing up just like on the other one that is on the other extruder. Then screws are going to go in here, and the arm is going to go just like this. Now what that means, of course, is that my filament is going to come up through this area here. As you can see, there's a hole right here that the filament is going to come through. And how does this work? So most filament sensors you find out there on the market, some of them are optical, some of them are higher end, but most of them just have one of these dumb switches in it. And all that does is basically, as filament goes through the sensor, it just flips this switch. And that's what I've got in here. The wiring will most likely not come on this switch, and you'll have to do that manually. And then what I have here, I have it wired to the normally closed mode so that when it hits it, it opens this circuit. You can actually wire it either direction. This is the way that's preferred. And you're going to set this in your firmware depending on which way you wire it. Now the way that mine works, very simply, This is going to mount right in here, and then as you put your filament into it, this is simply going to trigger this switch right through here as it goes into your extruder. It's a very simple design, but it's a very low cost design as well, and does exactly the same thing that the off-the-shelf sensors are going to do. Again, this is going to be adjustable. If this doesn't work exactly like you expect it to, you can easily bend this just a little bit either way, but I find that this design works very well. And as you can see, I even have a nice filament path built in here so that your filament should go in fairly easily. Usually when I am testing with it, I don't usually have to fight with it too much to get it to go through that hole and right into that extruder, which will be mounted right under here by the time everything is mounted up. So that's for that design. Oh, and the this is mounted just by, again, screws, T-nuts right here underneath the extrusion that the other extruder is mounted to. Now, just for the record, I do have a second extruder that I purchased here. This is the, as you can see, this is the Crowdy branded one. I wanted both of my extruders to mount, and I wanted to try these out. This is pretty much the exact same as the red one, but I have the red one already on that printer, so I figured at some point I would want to swap them out so that they would match. The final and probably most important component in this entire setup is going to be the Hotend itself, which actually does our filament swapping. So just as you'd guess, the filament is going to come in here and here from our two extruders. There's going to be a swap in this area, and then it will come out the end. I did have to get two screws that are long enough to mount this with, because the ones that are standard are not quite long enough. This is a little bit deeper than your stock extruder, so make sure you've got some M3 screws around in a variety of lengths so that you can pick the ones that best match your mount. Now, this is going to go on my ExoSlide system, so I'm guessing mine's going to be probably a little bit longer than the ones you need, so that's why I'm not really worried about how long these are. For the record, mine are 25 millimeters. That'll install pretty easily. I also have a couple of these couplers that easily attach onto here that keep my tubing nice and tight in here as this moves in and out doing the extrusions and retractions. So slightly off camera here, we're also going to obviously need plenty of new wires to get everything hooked up correctly to our main board. And I've got two wires here. First of all, you'll notice that I already have this one installed with a short wire. Now this is just so that we can easily detach this, just like we do with all of the other connectors on this printer. This is a really nice feature so that if anytime we need to make a quick adjustment, if we need to change out a part, we don't have to pull the whole printer apart to do it. So with that, I have the wire that's actually going to go to our main board, and you'll see here I've got two ends that I've put on this wire. This is a 3-pin connector because that's actually what's on the main board, and it's got 2 pins on it. It's just got a ground and a signal wire, and as you can see here, this one's going to go to our main board, and then this one easily connects to this connector right here, again for an easy hot swap. The other wire we need is obviously to our new extruder motor, and again, not much to this one. I have cut it to length and done a quick but strong coupling on here using these easy to install wire couplers that you simply melt in place. I really like these because it's really strong compared to anything that I could do manually, because this actually grips the wire. Now what I did to make this wire, this was pretty simple, is I had the wire that came with the motor, which was already wired on this end. Then I had an extension cable for the motor that I cut down to length, and so this is going to go into our main board. This is going to go into our motor, and this one, obviously it's not going to need that small extension like we did on the filament sensor. This one is going to just plug and unplug directly to the motor, so again, this is the only wire we're going to need to wire up the motor. final component that you're going to need, which I don't have in the picture here, but I do have nearby, is the Capricorn tubing that you're going to need to go to your new extruder. Again, you're going to have to cut this. Should be the same length as your other one because we're mounting it in relatively the same spot. You can buy these kits easily on Amazon. They come with the cutter. I just bought, I think, the 2-meter kit so that I would have plenty of extra. And that's pretty much it, I believe, for all the components that you're going to need for this installation. Now, I want to take a closer look at this. We're going to take it apart. We're going to see how it works. And we're going to see if we need this as part of our installation. So let's switch over, clean all this off, and take a look at the Hotend itself. So let's take a look at this dual input Hotend that I ordered, because we're going to need to know a few things about this before we go any further with our configuration. So first of all, you can see this is 2 inputs, 1 output on this Hotend, and we're going to dismantle it all the way down to take a look at how it's made, so that we know a few things that we're going to need to know, for example, in our firmware, and just to make sure that it's what we were looking for this project. So first of all, let's go ahead and take off the heat cartridge and the thermistor. So this is just going to be a Phillips screwdriver. We can pull that off. We're not going to be using the one it came with anyway. We're going to be using the one that hopefully is already in our printer, because that one should fit this without any problems. Let's go ahead and pull off that heat sock, because that's just going to be in our way. And now we are going to need a small hex head to pull this out of here. We're going to leave it in there so don't pull it all the way out. Now this should pull straight out because it's never been used before. Again, this is the thermistor and the heat cartridge right there. All right, this one that it came with was a 24 volt 40 watt, but we're not going to need that anymore. So now we're left with just the Hotend itself. Let's go ahead and start pulling this apart a little bit. We're going to pull off, let's pull off the top side of this first. Now you'll notice there are 2 inputs here for 2 separate hoses, and they've built this in pieces so that we can actually pull this off of here. That should come off. So you'll notice this part, this should be a no heat zone. There shouldn't be any extra heat coming all the way up to this part. This should be about where the top of the heat should get to. These are our fins here, so we shouldn't get any heat, hopefully above that point. Let's go and switch out one more time. We should be able to take these screws, which are holding on our heat block right here. There we go. Now this is just the heat sink. This right here, I'm going to pull these screws out so we don't lose them. So this right here is going to be the part that is taking most of that heat up to our heat sink. As you can see, this is not all metal, it is PTFE lined. One thing I worry about this as we go further, as we've been using it for a while, I do worry about damaging this internal PTFE component. And since this was an inexpensive part that I ordered, I don't know if I'll be able to get just this part of this. I may end up having to just replace the whole thing, but it was inexpensive. So hopefully that's not going to be a big deal if I just need to buy it for parts. Now this one screw from here, again, PTFE all the way down to the tip. That screws in just like this. Again, so one thing I noticed on here is that this only has moderate contact from the heat sink itself to this heat pipe inner part here, whatever you would like to call it. And so this is going to be a big concern of mine, because if we're not wicking heat away from this, this whole thing becomes a melt zone, which is definitely not what we're looking for. So I think what we're going to have to do is actually use some heatsink paste. Now this is just some that's usually used for heat sinks on PCs when you're putting on processors and heat sinks together. As you can see, it's just a tube of compound. So what we're going to do when we reassemble this, we're actually going to put some paste on here so that the contact between these two parts is much better than what it is out of the box. Now the last thing we're really going to need to do here is find out what the total length that we're going to have to retract in order to get filament from here all the way back up to where the other one will be out of the way. Because obviously when we have filament coming down through here, in order to be able to get this other one to be able to feed down in here, which is the second extruder, we're going to have to retract this one all the way back up into this area. So we need to measure from the tip of the nozzle all the way up into this area. So if I measure at least roughly, it looks like about 65 millimeters, give or take. Now we can tweak this later. We may have to go a little bit more, a little bit less, but I think 65 millimeters is probably a good starting point for our total retraction distance from here to here. Now when we go back and we want to extrude this back out, we may want to go a little bit further than that so that we build pressure back up. But we're going to have our purge tower where we're going to be purging out this nozzle, so I'm not too worried about that. We also may want to look at our nozzle, find out about how long we think we're going to have to purge. Again, the entire nozzle is probably about mid here. We're probably looking about a 15 millimeter purge or so, at least to get that to where it starts getting cleaned out. But only experimentation will really tell us what the average purge that we're going to need is. So we can put this back together now. So as I mentioned, let's go ahead, so I don't lose screws here, I'm going to go ahead and put this one back together. And the stuff I'm telling you about how this works, I'm explaining it to you because it can be used for any nozzle that you're doing. If you ordered a different product here, at least the fundamentals of what I'm telling you will be the same. The exact measurements and stuff are for this Hotend. They'll change depending on which one you order, but the methods will stay the same. So again, what we want to do here, we want to make sure that we have really good contact between this pipe again, which is going to be absorbing all the heat because that's coming straight from the heat block and from the nozzle. And we need it to have really good contact here. And right now, as you can tell, it doesn't. It's fairly good tolerance, but there's a little bit of wiggle. So what I'm going to do, I'm going to put out just a little bit of this heatsink compound on here. That's probably way more than I need. Pull back a little bit on this so it'll stop oozing out. And then it came with a spatula. Normally this would be used to smooth it out real nice on the heatsink of the processor, but we're not going to have that here. Now, I guarantee you I put way too much on here, but the basic method is what's important here, and if I have to wipe some off, it's not the end of the world. We don't want too much here because we don't want it oozing out. We just want a nice, smooth, even amount, and the more we can coat in terms of like top to bottom, the better overall thermal connectivity we'll have between the two pieces of metal. I do not want this really oozing out to where it's not supposed to be. Okay, pretty happy with that, and hopefully be just fine. So when we mate these two back together, notice this is off-centered just a little bit, and we're going to mate them back together just like this with the closer side towards the front of this nozzle area. And we're probably going to have some oozing here, which is fine. Okay, if we don't like that, we can pull it back out. Do just a little bit of cleanup. And that looks pretty good. I'm going to put it back together one more time. And again, this feels really good. I'm getting good contact. I can feel the two sort of going together. There's a little bit of run out there, but I'm not really concerned about that at this point. One thing I want to do, let's go ahead and back this nozzle off while we're doing this. Make sure we give it like just enough of a twist so that the nozzle maybe pokes out just a little bit. We're going to attach that together. That's what I'm talking about here. Hopefully I'm focusing, but I just want a little bit there so that I make sure it's making good contact. There we go. So turn it back around the right way, put back in our screws. Now I promise you, if you skip this step, most likely you're going to have heating issues on this Hotend. There we go. That's on there really good. Now I should be able to change out this nozzle actually without any problems, because I know that I can always retighten that And now that the screws are on here, I shouldn't have to take this apart unless I run this heatsink too hot and burn up that PTFE tube. It should last now. Now, the only thing else I noticed was that when you put this together, the silicone on this side does go a little bit over here, so I will probably snip this off to keep that from running into our heat cartridge. So just our usual snips. Just snip that off a little bit. Again, I don't know why they've moved that over here, but there we go. Now it won't run into those wires, hopefully, very much anymore. And that is our assembled heatsink that's going to have much better thermal conductivity than it had before. Now we're ready to install this on the printer. All right, first of all, let's attach the spool holder. Line up my T-nuts here. Again, I'm facing it backwards for now, at least on my setup. Do whatever works best for you on yours. Good and tight. Next up, we're going to install the extruder mount. Let's get a little bit closer. All right, so first of all, I have installed my T-nuts and my screws on here. I'm going to go ahead and mount this roughly in the same spot that this other one is installed. Make sure to get all my wiring out of the way so that it's easy to install. Line my T-nuts up. Actually, this goes around the other way. Let's do this right. All right, this goes around this way. All right, go ahead and get my smaller bit and install my filament sensor switch right here. And notice right here, I have already installed a couple of screws in here, and my wiring is of course already on there. This is simply going to go just like this, back in this hole. I can show you a picture of that later. And I need a Phillips head screwdriver to do that because that's the kind of screws I've got in here. It doesn't take much to screw these in. And we can test this by simply putting a piece of filament in here and seeing if we get a click sound, which we do. And you can see the filament come right out the top there, and we have a click. So there we go. We see that that is actually doing just what it's supposed to. Next up, I have already installed my gear on here. I did that ahead of time, and now we can install that in here. I'm going to put my wires off to the left, or my left. You can put them down, of course, if you want to. That's going to go in here. Then our actual mount is going to go on the front here. Then, doesn't matter which order you put these screws in, I am going to start with the top up here, just because I like anything that's hanging down. I usually like using the upper parts first. Of course, that should be threading into the motor. I don't need to screw these in all the way, at least until I got most of my screws in. This one up here. Then we're going to put in the countersunk one here that keeps it out of the way of the arm. Now I can go ahead and tighten these down because I've got 3 out of the 4 in. All right, now I can install the arm. I'm going to tighten that one down because the other ones are in. Then I'm going to take my spring, and the other screw goes in like this. Make sure I back that out. That one fits there. And this spring goes on the screw that's already in there. Tighten that in there. And then I can tighten this down and hold it all together. And once it starts to push on that screw just a little bit, it's tight enough. And that is a working extruder at that point. I'll have to hook this up once I get the wiring done. Go ahead and hook up our old extruder to make sure that I don't forget to do that later. I can go right there. And now let's move up to the top of the printer. Okay, so next up, let's install the new Hotend. We're going to just have to take this apart just like we have plenty of times before and install this. It should be a drop-in replacement. Now we should be able to pull this off by just taking these out. And since I'm using the exo slide, keep in mind this is going to look the same on any other mounting system for the most part, but you may have slightly different pieces. I've got these shims on here, which make mine look a little bit different than like the stock one. I'm going to reuse those, but these screws here I will not be reusing. I'm going to take this one. Notice when you take the sock off, and notice that this one comes in on this side, so that's going to be the direction that we have to mount this, just like this, with this sticking out the front this time. I'm going to pull the screw off of this one, and this one's going to need the extra long screws because, as I mentioned, this one's a little thicker. So put those in there, put my shims on, and we should be ready to mount this very carefully so that we don't drop anything. Notice this one's going to be a little looser because we're not using the same countersunk screws that we had on the micro Swiss Hotend. So either push up, push down, just to get it all leveled up. I'm going with up. It doesn't really matter. You just want it level on both sides if at all possible. Will help the extrusion come out level with the bed. Tighten that up, there we go. And we go on and we reattach our wires. Now this one has a set screw in the bottom of it instead of the two screws. So this hopefully will fit our set screw, and it does. I'm going to straighten this up a little bit. Then I can do our set screws. There we go. And grab the Phillips head again for the thermistor. Okay, everything should be in place. Put our sock back on. Okay, now we should be able to see if this mounts on here without any problem. I think it will if we line up the wires and everything correctly. Get the heating cartridge wire up into this area. Everything seems to mount. It's a little tight, but I don't think we have anything to worry about. We're obviously going to need to install the BL Touch, which goes underneath it. At this point, we can go ahead and actually unhook this one very carefully, just to make our lives easier. This is going to go underneath. Install this right here. Okay, all tightened down. So we can reattach our BL Touch. There we go, BL Touch, all working. Everything looks good here. That means we are ready to install our Bowden tube. So we'll take our first Bowden tube, which we already had. I'm going to simply push that over and hook it up right here. Just go as far down as we are. We know that there's a V here, so it's not going to go all the way down. So we'll take one of our coupler locks here, put that right in there, keep that from moving. Now we need our second Bowden tube. Okay, so I've taken my new cut of tubing, which matches my first cut of tubing in terms of length. This is actual Capricorn tubing. This is tubing from filament 1. I'm going to take this one, just put it back in my new extruder in the back. Take the coupler spacer, put that on there. We'll keep that in place. And then I want to take my new one and just put it right in here. And again, the coupler spacer, whatever you want to call these things, put that on here to keep that one from moving as well. There we go. So that's pretty much it for the hardware installation at this point. Now let's turn the printer over and do the wiring installation. So here we are with my SKR V1.4 Turbo. You could be using any mainboard that has a 5th or a 6th extruder, depending on how you have things arranged. So you will install your 5th extruder just like you did your other ones. We'll get to firmware in a minute on this. And then we only have 2 wires that need to be plugged in. This is a pretty easy mod in terms of wiring. First of all, new stepper wire. I'm going to plug that into this last port. Just like that. And then we have our second filament sensor right here. I'm going to plug that in right next to where our first filament sensor is, and it should go right into the board without too many problems, as long as I have made this connector well. And there we go. So here we are. Now that we have both of these installed, it should be pretty easy to take the other ends of both of them and get them installed right through the same hole that all of the other wiring goes through. It may be tight, but I do think that there is enough to get the connectors and everything through here. Now, I'm going to do that off camera. Those will go through that hole. They lead back up to the connectors that we've already put on the filament sensor, and the motor wire will go directly to that motor since we do not need a go-between motor connector. We should then be ready to go get our firmware modifications done. So I will patch all this back up, get it back up right, and we'll head over to the computer and I will show you what we need to change in our firmware. So here we are in a program that I like to use when I'm comparing source code trees or directories, whichever you prefer. I call them trees. And I can use this to compare a before and an after on my code base so that I can show you the changes I made for this modification. So what's important here, of course, isn't where I start, but just what I need to do for dual extrusion, and so that's what I'm going to be showing you here. And you'll notice I only changed two files as usual. I changed the configuration.h and the configuration_adv.h that is located in my Marlin directory. And I'm starting with my Bigtreetech SKR 1.4 turbo directory that I used when I had a single stepper hooked up for the Z-axis. So I'm just going to be using that second stepper driver that is now unused in this particular configuration for that second extruder. So let me show you what I've done here. So looking at the configuration.h, there's only a couple of modifications. I think you'll find this surprisingly simple. So obviously what I've got here, these blue lines over here on the right, are the changes I've made. First of all, of course, I'm going to change the number of extruders I have. I have 2 extruders, and I'm also going to set this define right here. And again, when I would want to set something that is unset, I'm going to remove the comment, which is the double slash at the beginning of the line. So you'll see this darkened here. It's changed 1 extruder to 2 extruders, and I got rid of the comment here, enabling single nozzle. And this lets it know that even though I have 2 extruders, I'm only going to be using 1 nozzle, so there won't be any offset that I need to worry about when I'm switching extruders. Now moving down to the next one, I am going to have to define my second extruder driver, which I have right here. So I turn on by removing the comment again. Here is extruder 1 turned on, and I'm going to set it to whatever driver I have on there. And for my purposes, this is another 2208 driver. Let's go down a little bit more. So with dual extruders, you have the choice. Do we treat both of them as 1 extruder in terms of the stepping and the calibration, or do we treat them as 2 extruders? And to me, it just makes a lot more sense that they are distinct extruders and they may have slightly different calibrations. So what I've got here is I've set this distinct E factors. I've turned that on by removing the comment. And then what I need to do in each of these different settings, I'm going to have to add 1 more comma with that default setting here. So I've done that for the steps per unit. I've got that for the max feed rate and for the max acceleration. And this last value here was the other extruder, and so I'm just adding 1 on here at the end for the second extruder. Moving down to the next change. So you'll notice here that because the first extruder is inverted, because it was set to true, I also need to invert my second extruder. And all that does is change the direction of the way that the motor turns when it's extruding filament. And then the final change in this file is right here, the number of runout sensors. Now, if you don't plan on adding a second runout sensor, you can leave this at 1, but you'll see, or you've seen in my mod, that I am actually adding a second runout sensor, so I need to set that to 2. And hopefully your board is already set up to define where that second runout sensor is hooked up on. Luckily, the V1.4 Turbo does have that setting already in the pins file. So let's go over to our configuration_adv.h and let's take a look at the changes I have here. So right here, if extruders is greater than 1, so this section of code here is only going to be applied if we have more than 1 extruder. Usually on a tool chain, particularly if you're moving around the nozzle, then you might want to do a Z-raise. And so there's a default Z-raise here of 2 millimeters. Now, With the way that we're switching with the single nozzle, I don't want to raise the Z, so I've got that set to 0 for mine. And since I want a little bit more control of the nozzle when the tool change actually occurs, I'm going to tell it that I don't actually want it to return to the position after the tool change. I'm going to be handling that in my slicer, so I'm going to get rid of that comment here, which is telling it to not return. So this next section here are things that I actually was thinking about using. I ultimately didn't because I decided to do this in the slicer. But if I got my settings really dialed in and then I wanted the firmware to actually handle the filament swap from extruder to extruder, I can actually have the firmware do that here. Now I would need to comment this line out because I would then be moving this tool chain filament swap to the actual firmware of the printer, but right now it's still commented out. And then I could set my length that I was going to be using for that filament change. And again, I've got some other options here that I could use in terms of repriming the nozzle and whether I needed to init that tool change on the first swap. Again, these aren't important. I decided not to use that in my particular configuration, but I did want to share that with you here. So that's it for the firmware. At this point, I can recompile. I'll get my firmware.bin file, and I'll be able to reflash the printer. You've probably seen that a lot, or you've probably done it yourself at this point, so there's nothing new about that process. Now let's head over to Cura, and I'll show you what I had to change there to enable dual extrusion, and particularly how I enable dual extrusion for a single nozzle printer. So here I am in Cura 4.7.1. Now when you go to create a new profile for this 3D printer, you obviously have the choice of modifying your existing Ender 5 Plus profile, or you can create a new one. Now the real benefit of creating a second one, as I've done here, is that in a dual extruder printer, most of the time, you can treat that printer like it only has one extruder if you're only printing with one color. So sometimes not having the additional settings and complications of the dual extruder setup is just easier. So I do recommend in a dual extruder printer to have a single extruder profile just to make it easier when most of the time you're not printing with two filaments. But anyway, I've created a dual extruder profile and I've got that right here. Now this then can be modified specific to your dual extrusion setup. Now in the machine settings, first of all, make sure to set your usual printer settings, your X, Y, Z. Make sure you turn on whether you have a heated bed or not. And of course, if you want to do any of your print head settings, you can do that here, but these are not usually required. Now, the number of extruders, obviously, we're going to change from 1 to 2. And what that's going to do is let the printer know I've got more than one extruder. It's going to expose this whole other tab, as you can see here on the right, that is going to be for our second extruder. It's going to expose all of the settings in here that are only for dual extrusion printers. And it's going to give me this second tab here, which I'm going to set up extruder specific items for that second extruder. Let me expand this out a little bit so that you can see this a little bit better. Let's go over the extruders first because I think that's easier. So in the first extruder, make sure you have your nozzle size set correctly. Make sure you have your material diameter set correctly. Now what I'm going to want to do is anything that I need to do at the beginning of a nozzle switch or at the end of a nozzle switch, I'm going to need to include in these areas here. Now again, if this was done in firmware, I don't have to make the changes in my slicer, but as I mentioned earlier, this is an easier place to make little minor modifications. If you need to change the length that you're going to have to retract and extrude, this is the place to do that rather than having to modify the firmware every time. So what I have right here is when we actually go to do our nozzle swap, what I like to do is go to the middle of our purge tower. And that's what this does right here. This is in relation to where I'm going to have my purge tower set in the actual G code for this model. And so I'm going to move the nozzle to X320, Y320, and I'm going to move at a rate of 5,000 millimeters per minute. And once I get there, I'm going to set my extrusion back to 0 so that I know where my extrusion length is. Now this doesn't do anything to the actual filament, it just tells my firmware that I want to start at a 0 point. And then what I'm going to do, I'm going to have to extrude 53 millimeters in order to get back to the nozzle because I will have assumed that I have retracted 50 millimeters, which is on this side, in order to get there. So what I've done by making this 53 instead of 50, I've got a little bit of a purge that's going to give me back pressure in that nozzle and make it printable. That is one of the reasons that I moved to the center of that purge tower, because that gives me some place safe to do a little extra extrusion, and then I will have the purge tower itself to wipe my nozzle of anything extra. This is kind of a neat trick. So again, I'm going to extrude 53, and at the end, when I'm done with that extruder, I'm going to have to retract 50 in order to get it to a safe distance to where it is not going to get in the way of this filament when it goes to extrude it. Now I know this -50, this isn't the number that I mentioned earlier when I was talking about the particular Hotend I'm using. This is a tuned one that I have figured out it works best for this Hotend. So for this Hotend, I do recommend these settings right here, -50 and 53. Again, that 53 being just for a little extra purge. And make sure that you copy and paste each of these to your second extruder. Notice as I go back and forth, these extruders are identical because they should be. The settings for both of these extruders should be the same because they are mechanically and physically the same distance away. They're the same motors. But obviously, if I had, for some reason, a different setup for different nozzles, that kind of thing, I could do different settings here. So those should be equal. Switching back to the printer, I have done a little bit of magic in order to set up start G-code that will hopefully give me a known starting point for my 2 extruder setup. Now, obviously, I'm not going to know where my printer necessarily left off last time. I'm going to hopefully set it up correctly, but what if I forget? What if I didn't have things set up exactly right? Or what if I just don't want to tweak it perfectly every time? So what I've done here is I've gone and set up sort of a start sequence. Like, this is what I want my extruders to do at the very beginning of each print. So I'm going to go again to that safe purge place somewhere on the bed. Now, I don't have a tower here yet because this is before any printing has begun. So I've chosen this X15 Y340 Z20. It doesn't matter where that's going to be. In fact, there may be a better place to do this than this, but this is where I chose for my testing. Then what I'm going to do, I'm going to switch to that first extruder, and I'm going to retract at least 50 to make sure that I'm clear. Now, I could have already been clear, but this is just going to make sure I'm really clear. And then on the second tool, I'm going to prime it. So I know my first tool, my first extruder is going to be out of the way. Now I'm going to prime that second one. So I just chose a number of 100 because it shouldn't be more than 50 away. If it was more than 50 away, this is going to give it a little bit, and this is going to clean out that nozzle. This is going to make sure we're at a known location. And then once we've extruded 100, we're going to just back up 50, which is going to put that second extruder in a known position. We will know at this point that we are 50 millimeters away from the nozzle. At that point, then we are going to do the same thing again with that first extruder, and we're going to extrude 100. And then what we're going to do is just back up a little bit. We're going to back up like 5 millimeters just to make sure that we're not oozing at this point, and hopefully snap off anything that is sitting on the tip of that nozzle. Now we've set it up where our second tool, our second extruder, is 50 millimeters away, so it's ready to be the second thing that extrudes. And we've set up our first tool, our first extruder is actually in the nozzle, it's hot, it's ready to go. And then we're going to do our normal things. We're going to do our normal purge lines, which is what you see right here, and we'll be ready to go. I don't need any special NG code for this setting, so that's all we'll need here. Backing out to the regular settings itself, what we have here is most of these are my usual settings. We only have a few settings that are going to be specific to dual extrusion. So let's look for those here. So the first setting we come to that is specifically for dual extrusion, you'll notice that when we do supports now, we can assign which extruder is going to be for the support. So for example, if I'm doing a special filament that is for breakaway supports or a special filament that is for dissolvable supports, I can choose which extruder I've put that on. So just extruder 1, extruder 2, you can decide where that's going to be from that point forward. Now as we go to the build plate adhesion, again, which extruder is going to be our filament that we use for our build plate adhesion, and we have that right here again, extruder 1, extruder 2. Then we have an entire section set up for specific things for dual extruder printers. So again, this is where we're going to enable our prime tower. We're going to have to pick a prime tower size. For this particular printer, I knew I needed it to be at least 30 millimeters, and you can calculate this or you can test this. And I know the minimum volume I'm going to need is 60. Again, this was from testing. Keep growing this number until you find out that yes, I have cleaned out the color from one extruder to the other extruder. And of course, this is where I'm going to set the prime tower position. So this is going to be the corner of that prime tower that we need to set, and this is going to also play into that number that I put in my start and my nozzle swap G code. Now actually I need to change this number back. This was something I was playing with. So there's this nozzle swap retraction distance. For certain types of nozzles, you may want to retract extra when you are doing a nozzle swap, but we're not actually going to use this. I found out that if you use this instead of just doing it manually like I've done in the start and stop G code for each extruder, what you run into is that it doesn't always work correctly because it's assuming it only has to do it on swap. So particularly it fails at the beginning of a print where it has never swapped anything before, and so it doesn't know to do this. So I'm going to zero this retraction distance out because we have already taken care of this in that start and in G code. Again, this isn't going to come into play because we're not using it, and that's going to be about it for the settings. Now keep in mind, any settings we set up here may not carry over into this second nozzle tab. So be sure if you change anything in your first nozzle, that may also apply to your second nozzle. Do not forget to manually copy it over to nozzle 2. Otherwise, you're going to be confused as to, hey, I changed that. Why is it not working all the time? Well, this was probably why it didn't work all the time, because I didn't copy it over. So that's about it for the slicer. At this point, we can slice a model. All right, so I've brought in this 2-color Charmander model, and this can be found on Thingiverse. And you'll notice what I've got here is it comes in 2 different pieces, and you'll find 2 separate STLs when you download these. And this is the body, and this is the details. Now what you'll need to do, first of all, is set which extruder you want for each STL. Now when I right click on this one, notice this one is already set to be extruder 1, but when I click on this one, it's also extruder 1, which is obviously not what we want. We want this to be dual color. So I'm going to select extruder 2 on that one, and as you see, it changes color to signify that it is on a different one. Now what we'll need to do before we slice this is select both parts holding down the shift key. We're going to right click, and then we're going to say merge models, and it will figure out how those go together, and now it's one model ready to slice. And I can then slice that model and do a preview on it. You'll notice that I had supports and everything on here. I'll turn those off before I actually go to print this. Let's see, and you can see if I go in here, the colors really aren't set up correctly, but you'll notice if I want to show which extruder is which, I can select and deselect these, and it'll show which one is which. And then I'll be able to save that or send it to Octoprint or whatever I want to do, and I'll be ready to test this printer out. So let's do some test prints. Let's find out how this works. So now that I have everything running, let's take a look at some of the results I've been getting. So as you can see, I've got 2 examples here of Charmanders that I've been trying to print in dual colors, and this is a good example of what I've been seeing, where it prints a few layers. It looks like it is swapping back and forth between the filament correctly, but ultimately it gets hung up. And as you can see, this is a good example where it's trying to push filament through or it's trying to switch, and I'm just getting whatever garbage is left in the hot end, just oozing out basically. So what I did is I started playing with the hot end a bit, and I realized that I'm getting something caught up. And I've played with different retraction settings, and I have played with different speeds, and it doesn't seem to really matter. If I retract far enough to actually make the filament swap happen, I'm getting it hung up a bit. So I think what I'm going to have to do in order to really figure out what's going on is I'm going to have to pull back apart the hot end and take a look at where it may be catching that filament. So that's what I'm going to do now. Let's head back to the bench, pull apart the hot end, and see what's going on. Basically what I've been noticing as I've been working with this hot end is that occasionally the extrusions just will not get through the hot end. Basically it comes in here like this, and as you can see it gets hung. And we're not very far in, we're only about that far. So that's about the point where we have a transition from this component at the top to the rest of the hot end. So what I want to do is pull this apart and find out exactly what's going on. So I'm going to take this top part back off. We're going to see where it's getting caught. My guess is that since this is an inexpensive part, we have a manufacturing issue of some sort. So now first of all, we notice right here, this component is just where the hot end enters, and as long as this is straight and ends up in this hole correctly, everything should be fine. So let's take a look at this part first. So if we come in here and we push it here, what do we see? We see that it's getting hung up. There's actually a lip right here. And unless it comes over just right, it will not get through that hole. And it will definitely stop that filament from getting through here. Now this is a huge manufacturing issue, and I can't imagine what in the process left a lip right there that is going to block our filament unless things are just going through just right, or unless that tip is rounded just right. This is definitely a non-starter for a reliable system. So the only thing I know what to do to try to salvage this hot end is to drill this hole out a bit to make sure that it's smooth, and then we'll have to see if we recombine these two pieces, does it get hung up anywhere else? So let's do that. First of all, I've got my metric drill bits here. I'm going to find the one that it currently fits, and then we're going to go up from there. So this is a 3mm, and that doesn't quite fit. From there we have a 2.5mm, and that one does fit. Now I can tell by just pushing on here, we're not going to have very far to go. If we go too far, we're going to be hitting that Y adapter, so we're going to have to be really careful when drilling this out. But that 2.5mm, let's do it with the round end. But that 2.5mm actually does just barely fit, so that's not what we want. So we're going to go ahead up to the 3 and see if that will get rid of that lip for us. And again, we're going to do this really slowly to see if we can get everything working. And I've got the drill on drill mode. And if I have to, I will vise this so that we don't run into any problems, because I'm not going to hurt myself drilling this out. And it could get caught. So if it does, there we go. Again, I'm holding it back here. I don't want to drill out any further than I have to, because I don't want to damage this piece. That's pretty good. I see in there that I am actually leaving some spurs on the inside, and there's not much I can do about that because I can't drill from this side, at least not very easily. I could try to pull this off and see if I could drill from that way, but we know that the lip is on this end. So let's see if I made that better or worse. It's actually a little bit better, but I'm still catching the lip on this side, so it definitely didn't go around all the way. Let's try this side. Same thing, catching the lip over here still, so I didn't get that drilled out all the way. So let's go up to the next size up. This drill bit set, I will see if it's still available and link to you in the description. This is a metric set I got off of Amazon. That was 3, and then it nicely steps up to 3.2, which is going to be just barely bigger. Since it's going well, I'm going to go a little bit faster and try to clean that out. Let's see if that helps. That is almost there. I'm still catching it on this side. Let's check the other side. Again, really close, still not quite there. So next up in my drill bit set is the 3.5. So we're gonna do that one next. Moving up like this is also keeping this from catching on it really bad, because if I go up gradually, then there's going to be less metal for it to catch on. I am having to hold it pretty good. Uh-oh. Maybe grabbing something else there, so I'm going to be more careful. Now I believe a handheld clamp will work just fine for this, because I am not really needing to hold it that much tighter. If I have to, I'll get the vise, but I think that this should be good enough because I can still get a good grip on this. See what we're grabbing there? I think that's good. And let's do this again. There we go. Try one more time. There we go. So now it is no longer catching on that edge. Let's try the other side. Again, no longer catching on that edge. And I actually can see inside of here. You probably can't with this lens, but it looks really, really clean now. It's going all the way around. So I can tell I've gotten rid of that lip. So now let's go ahead and reassemble this and see if it still catches, or if we can get all the way into that hot end without it actually catching on anything. So again, that was the 3.5 millimeter drill bit that got me there. There we go. Okay, let's try this again. See if we can get all the way through. And see, now I'm going directly into that hot end with zero problems at all. The thing about that Teflon tubing, that PTFE that's in here, it already has a funnel shape to it. So that's going to actually help me quite a bit get this in and out of here every time without catching. What I'm catching on here is just the lip of my coupler here, which will no longer be a problem once I actually have tubing in there. So we're going to try this again with whatever my last working retraction was, and see how that works. So this is how most of the prints turn out. If you notice, it, for the most part, did pretty well. I've got dual color extrusion going. The orange looks particularly good, but the yellow, not so much. And this is the same brand of filament on both reels. Unfortunately, this is just what I get. It ends up clogging about here, or maybe a little bit lower sometimes, and then it just does not complete. As you can see, this was a full print, but it did clog up somewhere along the way. So this is the kind of prints I've been getting off of here, just constant clogs. And as you can see on these rows, you just have problems, and so far there's been nothing I can do about that. So this is where I am at this point. So that's what got me to where I am today. Let's take a look at what's going wrong and why I'm going to call it quits on this particular hot end. So here's the hot end as it stands right now. As you can see, the Bowden tube that I've got here has been disconnected, and this is completely stuck. And what's special about the way that this is stuck is it actually moves. It's not stuck, probably not stuck in this area. I think that because of that drilling out, that it's most likely stuck right behind this coupler in this area. There's only one way to find out. So what I wanted to do is pull this apart right here and see if that's what I'm going to find. So first of all, I'm actually going to just take this off to see if this is enough to get it off. It's stuck there. It is not stuck there. But is it going to be stuck in this area? So this was during a print. I've already removed the print from the bed because it was in the way. But as we'll see, I can actually pull this apart, which is kind of nice. I can pull this apart with the cooler on still. Does this solve the problem? There we go. So it is right there now. As you can see, we still have a gap and that's not going to focus very well, but we still have a gap right here. And what happened was, I'm going to have to find that later, but what happened was is now we have this big nodule of filament during a normal print process getting stuck right in this area. So we're still ending up with a problem of this hot end not having a good path for that filament. At this point, I could keep working on this, and I might, but I'm not happy with this hot end out of the box. So you see where we are. Made a couple of repairs already to this hot end. It's still going to need some more work. Honestly, though, I'd rather find something out of the box that was going to do a better job at this. So that's where we are today. Let's sum up what I've learned on this project and what you've hopefully learned on this project. So let me sum up what was all involved in this mod today. First of all, there's the selection of the components that you're going to need to actually do the mod, and then that's divided into two components. Number one, what can I buy? Things like the hot end are components that we know we're going to need to buy, and then there are what can we model. And as I showed you, I modeled my own extruder mount, which also had the filament runout sensor, and I also modeled a new filament holder because I wanted to match the old one, and I didn't know of an easy way to buy that sort of filament holder. So once you get all that printed out, then you can begin actually doing the hardware mod itself. Now from there, we have to modify our printer's firmware to actually be able to use the new extruder setup. So I walked you through the few changes that needed to be made there. Now finally, there is the slicer. And the slicer is going to control all those little bitty things that you have to do. As I showed you, a lot of retraction, a lot of feeding into the new hot end in order to tweak that, in order to get a good print out of it. And there's a lot of things that you can do to kind of tweak that, just like you would with a single extruder. Kind of the same things, but with the added complication of having to swap out those two different extruders and the two different pieces of filament out of your hot end. So I walked you through all of that. And in the end, unfortunately, like I said, didn't really succeed in what I was going for. I'm really not happy with the way this hot end is designed. And so I don't have a working setup. But I really do hope that the whole process was educational. I hope this was able to show you how I'm going to do this. When I get one or two more hot ends in-house to be able to test this again, I'll hopefully come back and do a part 2 that actually shows this working so that you can duplicate this setup. Now, what did I like about the overall process? Number one, I'm overall very happy with my hardware design. I'm happy with the models I made. A couple of them are the easiest to print, and as I showed you, the filament spool holder does require a special type of filament. Otherwise, you're going to really have sagging, I believe, with PLA and probably with PETG. You may be able to use ABS, but again, without an enclosure, you're really going to have to watch warping on something with that flat of a bottom on it. What am I not happy with? Well, I would really like a solution that had the filament swapping actually part of the firmware. I would rather simply tell it to switch tools, it know what to do with that, and then not have to worry about it. That's what other printers I've seen actually do. The tool switching handles that, so you don't have to worry about it. But the beauty of actually having that in your slicer is that you can make minor changes to it if something's not working exactly as you had planned. So it's not all lost by not having it in the firmware. It gives you a little bit more flexibility for the future. So that about does it, but I do want to know, do you know of any other hot end that you've used yourself that would work better than the one I tried, or one that you've seen that you think has a lot of potential? Obviously, I know of a few others on the market, ones that are going to cost you a bit more, but ones that are probably going to be more reliable due to better engineering. But I do want to hear what you have to say. Leave a comment down below with the other hot ends you think I should try. And obviously, leave comments down below. Did I do anything that you think that there's a better way to do it? Do you have any questions about the process that I went through? Please leave those down in the comments as well. I always try to get back to as many of my comments as possible. As always, thanks for watching this video and for making it all the way to the end here. If you want to support this channel further, please leave a like on this video. Go ahead and subscribe, comment. Be sure to share this with people that would also enjoy this kind of comment. That's how I bring in the extra subscribers, is by you recommending this to others. I really appreciate it. If you'd like to support this channel even further, I have my PayPal and Patreon links down below. I appreciate all you that have chosen to join me on Patreon. Thank you for your support. And hey, I'm Chris as always. This has been Kersey Fabrications. I'll see you next time. I'm Chris as always? Yeah, of course I'm always Chris.